All right, in this video, we're going to look at how to differentiate powers of x. So we're going to do this using rules of differentiation. There are several rules that we're going to list here, then we're going to use them to find derivatives of functions. The first one is says that the derivative of k with respect to x is 0. So this one is basically saying the derivative of a constant is equal to 0. Derivative of a constant is equal to 0. Then the second one says derivative of x to the power n with respect to x is n times x to the power n minus 1. This is probably the most important of the rules we're doing here. So this one is saying when you differentiate a power, first you multiply by the power, and then after that you subtract 1 from the power. So that's what we're going to be doing repeatedly. The third one says the derivative of a constant times a function is the constant times the derivative of the function. So basically, this rule is saying when we've got a constant here times a function, we can factor it out of the differentiation process. The last one says that the derivative of a sum is equal to the sum of the derivatives. So this is saying that if we need to differentiate a function that is made out of a sum, by the way, sum also includes a negative there. So to differentiate that, we simply differentiate the respective functions separately, and then we add the derivatives. All right, so let's have a look and work through some examples. So here we have got several functions. We are going to find their derivatives using the rules of differentiation. In two previous videos, we used the limit definition, which method takes a bit longer. In fact, in that series of videos, we derived this rule number 2 here. But you're going to notice that using the rules of differentiation, we managed to get the derivative much quicker. So let's start with example number A. Okay, so we have got here f of x equal x to the power 3 minus 2x squared plus 4x minus 9. So the derivative of this df dx using the property of sums. So to differentiate this, we simply differentiate each of these terms separately and then add those derivatives up. So for the first one, we are going to so differentiating a power involves multiplying by 3. So we're going to multiply by 3. Then we are going to subtract 1 from the power. And for the next term, again, we multiply by 2. Then we subtract 1 from the power. For the third term, the power is 1. So we multiply 4 by 1, and then we subtract 1 from the power. The last term is a constant. Derivative of a constant is 0. So that one is simply going to be plus 0. Then we tidy this up, so that is going to work out to 3x squared. This one is going to be 4x, and the last one is going to be 4. And that is the derivative of our function. Right, going to number B, we've got r, it's a function of t, so r is given by 4 square root t minus 7 over t squared. Now, this function, we need to rewrite it before we can apply our rules here. Notice that x here is a power in the numerator. So that's like same as x to the power n divided by 1. So here we need to rewrite this. This, for instance, is a power in the denominator, so we need to bring it up to the numerator. This one is a radical. We need to write it as a power. So we're going to rewrite r as follows. The square root is the same as power of a half. And then this one, if we bring the t to the numerator, then it becomes t to the power negative 2. So notice here, this is still r. We haven't yet differentiated. We're just rewriting it in the form where we can use our rules. Now we are going to differentiate because it is in the form where both of them are powers, and both of those powers are appearing in the numerator. So for the first one, the power is 1/2. So we multiply by 1/2, and then we take away 1 from the power. For the second one, the power is negative 2. So we are going to multiply by negative 2 and then take away 1 from the power. Simplifying here, 4 times 1/2 is 2. And then 1/2 minus 1 is minus 1/2. Negative 7 times negative 2 is 14. This is going to be power negative 3. We can now rewrite this as 2 over square root t. This one is going to be 14 over t cubed. And so that is the derivative of our function r. Going now to example number C, we have got g of u. Now g of u is u squared minus 2 over square root u to the power 2. So again, looking at this, okay, these terms inside, this is, we can differentiate, but we've got this power 2 outside. This one is in the denominator, so similarly to what we did to this term, we'll have to bring it up to the numerator. But the main thing that's happening here is this power 2 here. So that power 2 we need to expand first. So that means when we get a function that can be simplified algebraically, before we do the differentiation, then we've got to expand or simplify that function first. So always we simplify algebraically first before we apply the rules of calculus. So in this case, we're going to have to expand this. So it's going to be this squared. So that's going to be u squared squared. Then it's going to be minus 2 times this times that. So it's going to be 2 times u squared times 2 over square root u. And then the last term is going to be the square of that. So 2 over square root u all squared. And then simplifying this, the first term becomes u to the power 4. Second term becomes u 4, because we've got 2 times 2 there, 2 times 2. So that's going to give us 4. Then that's going to be u squared over square root u. Square root u is power half, so it's going to be 2 minus half. So it's going to give us 4u to the power 3 over 2. and then the last one is going to be 4 times over u, so it's going to be 4u to the power -1. Now we are in a position to differentiate this, so I'm going to use the prime notation this time. Again, in the video on the derivative entitled derivative 1, we talked about the different notations of differentiation. So here, if we multiply by 4, it's going to be 4. If we subtract 1 from the power, it's going to give us half. For the next one, we multiply by the power, which is 3/2. We subtract 1. And then for the last one, we multiply by -1. We subtract 1. Okay, then simplifying, tidying things up, 4 times 3/2 is 6. 3/2 minus 1 is 1/2. And then this one is going to be plus 4 times -1. Then we're going to have 2 to the u to the power -2. So then again, if we wish, we could write this as 4u cubed minus 6 square root u plus 4 over u squared. So that is our example number C. Then going to D, in D we have got y equal the square root of x times 2 times x minus 4 over x cubed. So again, here we're going to remove brackets first. So just simplify this first. So we're going to have 2x times square root x. Perhaps what I'm going to do, just going to write the square root x as a power, and then this is going to be 4x to the power half over x cubed. And then we are going to have to simplify. So this is x to the power 1 times x to the power half. So it's going to be x to the power 3/2. So typically here, when we have got fractions, we express them as single fractions. So this thing, for instance, as opposed to writing it as 1.5, we write it as 3/2. And this one is going to be 1/2 minus 3. 1/2 minus 3 is going to be -2/2, which is -5/2. So we're going to have -5/2 there. Then now we can differentiate. So when we differentiate, so multiply by the power here, subtract 1, so 3/2 minus 1, 4 times the power, and then power -1. Then we tidy this up. 2 times 3/2 is just going to be 3. 3/2 minus 1 is 1/2. 4 times 5/2 is going to be 10. And then minus 5/2 minus 1 is going to be -7/2. We can leave that one in that form. Then in E, we have h of v given by v to the power 5 minus 2v squared plus 3, all divided by v cubed. So again, we're going to have to simplify this first. The way we're going to simplify this is by using this distributive property of division, which says that a plus b over c is a over c plus b over c. So here we can write this as v to the power 5 over v cubed minus 2v squared over v cubed plus 3 over v cubed. Then all we do is to use properties or laws of indices. So for the first one, it's going to be v to the power 5 minus 3. So it's going to be v squared. This one is going to be v to the power 2 minus 3. 2 minus 3 is 1. Here, if you like, you can write this as 3v to the power 0. It's going to be 0 minus 3. So it's going to be 3v to the minus 3. These are now powers in the numerator, so we can apply our rules of differentiation. So dh dv is going to be, for the first one, it's going to be 2v to the power 2 minus 1. Then this one minus 2 times minus 1. V to the power minus 1 minus 1. And then 3 times minus 3. V to the power minus 3 minus 1. So simplifying here again, it's going to be 2v plus 2v to the power minus 2 minus 9v to the power minus 4. We can write these as positive powers. It's going to look like that. All right, we are now going to give you a few to try. Okay, so please have a go at these ones here. So that is the function in f, and there is g of u, and then that is h, and the last one is this one here. So if you'd like to just pause the video at this point, have a go at them, and then when you continue the video, then you can compare your answers with ours. Okay, we are hoping that you have now had a go at these. So let's see what f looks like. So in f, the first thing we're going to do is to rewrite these two terms here, because in both of them t is in the denominator. So bring t in the numerator here and write the square root as a power. We're going to have 6t to the minus half. For this one, I'm going to have 7t to the minus 1. Now all of them are powers in the numerator, and so we can differentiate. So the first one is a constant, derivative of that is 0. Here 4 times 2 is 8. 4 minus 1 is 3. Next one, 6 times minus half is negative 3, so that becomes plus. Minus half minus 1 is minus 3 halves. 7 times negative 1 becomes negative here 7. Then minus 1 is minus 2, so that's going to be our derivative for f. In g again, we need to simplify this here, so just remove the brackets. So this times this is going to be 4u squared. This times this is minus 6, and this times this is plus 2. So it's going to be minus 4, and then this times this is 3 over u squared. Then again, this u squared, we need to bring it up to the numerator, so it becomes minus 3u to the power minus 2. Now differentiating, so 2 times 4 gives us 8u. This is a constant, so it just gives us 0. Minus 3 times minus 2 gives us 6. Subtracting 1 there, we get minus 3. And then we can write it like that. So here we're going to have to divide using the distributive property of division. So divide all this by x to the power half. So first one works out to x to the power 2.5 is 5 on 2. This one 4x to the power half. This one simply take the x to the power half up. so the power becomes minus. And then now when you differentiate, we multiply by 5 on 2 here and subtract 1. So that becomes 3 halves multiplied by 1 half here, subtract 1, multiplied by negative half there, and subtract 1. So we can write this in terms of radicals like that. For I, again, first thing I want to do is to simplify. So if we expand this, we are going to get t plus 4t to the power minus half, and then plus 4t to the power minus 4. This is the same as t, 4 over t to the power 4. Then when you differentiate, derivative of t is 1. This one is going to give us minus 6t to the power minus 5 halves. This one is going to give us minus 16t to the power negative half, and that we can write like that. All right, thanks for watching. Yes, please, hopefully this has been useful. Please do subscribe so that you can get notified. You can put your comments as well in the comment section. Thank you.